Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about...
Before starting with what industrial communication networks are, it is important to know the automation pyramid. The automation pyramid is made of 5 levels, which are found in an industrial environment. The technologies are related to each other, both within each level and between the 5 levels through different industrial communication standards. In the first level, called the field level, are the physical devices. For example, actuators and sensors. In the second level, or the control level, are the controlling devices that can be computers, PLCs, PIDs, etc. At the third or supervisory level, SCADA is used to supervise. And this is where the previous levels are combined to access data and control systems from one place, where multiple systems can be monitored and controlled. In the fourth or planning level are the manufacturing management devices, or MES, which monitor the process from the beginning to the final product and shipment, as well as being where most errors in production versus demand are detected. In the fifth or the management level is the enterprise resource planning of the company, or ERP, where the company monitors the level of its manufacturing processes, sales, purchases, etc.
Traditional industrial networks are used to allow data communication between computers and their peripherals, and between other devices, and are at levels 4 and 5 of the pyramid. On the other hand, industrial communication networks are a special type of network made to handle real-time control and data integrity in difficult environments over large facilities, and are at levels 1, 2, and 3 of the pyramid. The use of industrial communication networks can be classified in two main areas: that which is at field level and that which goes towards SCADA. There are different types of networks, which depend on the environment in which they will be installed, and these are: factory networks are used for office, accounting, and administration networks. The volume of information exchanged is high, and response times are not critical. These systems work primarily with systems based on the Ethernet TCP/IP standard. Plant networks are used to interconnect models and manufacturing cells with each other and with departments such as design or planning. They are often used to link engineering and planning functions with those of the plant production control and operation sequencing.
These networks must handle messages of any size, detect and correct transmission errors, cover large areas, manage messages with priorities, and have a wide bandwidth to support data from other subnets such as voice, video, etc.
Cell networks interconnect devices that operate sequentially, such as robots, CNCs, PLCs, and AGVs.
These networks must manage short messages efficiently, be able to handle discrete event traffic, have error control mechanisms, possibility of transmitting priority messages, installation and connection per node must be cheap, and must recover quickly from abnormal events on the net, and it must be hi-fi.
Field buses replace the wiring between sensors, actuators, and control elements. This type of bus must be low cost, allow serial transmission over a digital bus with the ability to interconnect controllers with all types of input-output devices, must be simple and allow intelligent slaves. Manage short messages effectively, be able to handle discrete event traffic, have error control mechanisms, transmit priority messages, have low installation and connection costs per node, be able to recover quickly from abnormal events in the network, and respond to messages received in the same way. Generally, they have a small size that can vary from 5 to 50 nodes. They use the traffic of short messages for control and synchronization between devices, and the transfer of files is occasional or non-existent. Depending on the amount of data to be transmitted, they are divided into high-level buses, device buses that transmit few bytes, and actuator sensor buses that transmit data at the bit level, but in no case do they transmit large blocks of information.
The advantages of using field buses are the best quality and quantity in the data flow, savings in the cost of wiring and installation, ease of expansion or reduction of the number of system elements, reduction of errors in the installation and number of terminals and connection boxes.
Factory and plant networks have an homogeneous implementation based on Ethernet. On the other hand, communications at the field level do not have that homogeneity, which often makes it difficult to integrate equipment from different manufacturers. However, I can tell you that the most prominent are Profibus and Foundation Fieldbus, of which I already have videos. Even so, there is a lot of diffusion of ASI, Longworks, Interbus, DeviceNet, Modbus, ControlNet, WorldFib, FIB, HART, of which I also have a video, etc. Ethernet technology is also implemented in low-level industrial networks for real-time systems. Another important aspect is the security of these integrated systems, because by being integrated into administrative and process control networks, the control systems are more exposed. The most common control scheme is the master-slave, constituting a centralized control system that must collect information from the production plant. This master-slave integration is used in equipment based on PLCs, where these are the master and are in charge of managing remote models of sensors, actuators, and even other PLCs in charge of managing local processes. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adios!
These networks must handle messages
Vary too.